Hello, geometry students. This is Mr. Fugay, and for today's lesson, we are going to talk about the triangle congruence theorems, or otherwise I like to call them the triangle congruence shortcuts, because they're going to help speed up our work based on our definition of congruence. Now, up to this point, prior to watching this video, hopefully you've done two things. One, you've completed either the triangle construction paper project, where we were cutting out different triangles and putting them on the board, and we've talked about them, or you've completed the equivalent Desmos activity that I have there as well. So you've done one of the two. Also, hopefully you've also watched this first video right here, Triangle Congruence Theorems Explained. The Mashup Math YouTube channel does a really good job helping to visualize and to help you understand why these 7 theorems, or actually 5 theorems we're going to talk about, why they work and why they're able to prove that two triangles will indeed be congruent to one another. So if you've done those things, then you have come to the right place, because we are now going to formalize some of that language and talk about how we can show work for various problems. By talking about the various theorems and which ones work and which ones will not work for congruence. So the first one was our orange triangle, which we are going to call now the side triangles, or SSS. Now, for those triangles, what we need to know is we have to know that all corresponding sides are congruent. In fact, let's write that in there. Let's write the word all corresponding. All corresponding sides are congruent. So in this case, we're actually looking at the 11 and the 11. Then we have our 14 and our 14. And lastly, we have our 18 and our 18. Sometimes you won't actually know the measures. Instead, maybe you will see congruent marks, and we'll see those later on in the lesson. So once we've proven that, we can actually say that triangle ABC would be congruent to, so we're going to pick the same corresponding angles here. So it would be triangle DEF. And those work. Now let's talk about one that doesn't work, and that is the angle triangles. So those were the yellow triangles you created, and hopefully what you saw there in the class was that they were all different sizes. In fact, these aren't going to be congruent. These are actually going to be something called similarity. And we're going to talk about similarity actually in this unit, but a little bit later on. So for today, we're talking about congruence, and what we can conclude is that these triangles will not be congruent. So all angles are congruent. That does not give us enough information to prove that the two triangles are indeed congruent to one another. All right, so we've looked at all 3 sides and all 3 angles. What about a mixture of sides and angles? So the blue triangles we actually call our side triangles. And what's really important here is that we're going to have 2 sides that are congruent, once again, corresponding sides. And we have that here. We have our 11 and we have our 14. So that looks great. But what's key here is that the included angle, and I'm going to write that in a different color here. Let me change the pen here so you can read that a little bit easier. So included angles are going to be congruent. So what that is important is because you'll see that in the next triangle, the included angle has to be the angle that is contained by the 2 sides that we know. So in this case, the 11 and the 14. So since the 11 and the 14 are the 2 sides that make up our 30-degree angle, we would say that this 30-degree angle is an included angle, and that means that we can actually use side angle side as our reasoning of why we know these 2 triangles are congruent. So our triangle congruence statement here would be triangle MNO, so that goes across the side that's 14, and then up the side that's not currently marked. So its corresponding name would be RQP for the triangle on the right. We then have our side angle, and this, as you hopefully saw from the video, is not going to work, and the example down here below should demonstrate that. We can actually get 2 different types of triangles, and we probably saw that from our class activity as well. So what this tells you is, number one, this is going to be a no, but it's 2 sides and then the non-included angle. So I'll say included angle. So what you should see here is that, like, we have our 18 and we have our 14. Those are the 2 sides we know. Notice that the 30-degree angle is not between the 14 and the 18. So we would say that this is a non-included angle, and that's the reason that this is going to be side angle, which means it will not work. Okay, we have 3 more to go, and the good news is all 3 of these are going to end up working. So let's start with angle, side, angle. That's going to be abbreviated ASA. And by definition, this is where we're now going to have 2 angles. And the key word here is their included side. So let's talk about what included side means here. So if I go back up here, we have our 30-degree angle and we have our 105-degree angle. So there are 2 angles. So the included side would be the side that contains or touches both of those angles. So in this case, the 11 is indeed between the 30 degrees and the 105. So that's the reason we would call this ASA in this situation. The congruent statement here would be triangle CBD when we're going in corresponding order. Now, the other type, angle, angle, side, is also going to work. So this is still going to be a yes, but the difference here in the definition is that we have 2 angles, and then the key word here is the non-included side. So just to show you why that works, so we have the 105 here, the 105 here, we have our 45 and our 45. Notice that the side length that we currently know is congruent is not touching the 45-degree angle, it's only touching the 105. So we would say by definition this is a non-included side, and our congruent statement here would read IJH. Let's talk about our last one. The very last one is called hypotenuse leg, and this is really important because this is different than the other 6 I've just talked about. So hypotenuse leg is abbreviated HL, and its definition is when the hypotenuse and one of the legs of a right triangle. I'm going to highlight that because that's really, really important that we identify that the triangle is a right triangle, because this will not work otherwise. That will be congruent. So right here, right away, we're seeing the right angle here and here. We know it's a right triangle. We know that my 14 is going to be my legs, and you can see that I have a pair of legs that are equal. And lastly, we have our 18, which is going to be our hypotenuse. And because those are the same, we know that this is going to work. So our congruent statement here, KLM is the left triangle. The right one would have to be called PON. So when we come back as a summary here, just before we move on to some practice at the end, that we have 7 different possibilities of angles and side combinations. And of those, the ones that are going to be congruent, let's summarize them here on the side, is going to be side, 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 angle, side, angle, side, angle, 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 side, and finally hypotenuse leg. The ones that are not going to be congruent, or we would say not enough information in those situations, would be our angle, 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 or our side, side angle. Those are the ones that will not work. So let's go ahead and take this and put it into practice. So looking down at these first 3 examples, I want you to take a moment to pause this video, and I want you to identify which of the congruence postulates, or which of the congruence theorems, I should say, are going to prove that these 2 triangles are indeed congruent to one another. Go ahead and pause and try that out. Let's go ahead and talk about this. So in the first example, I see that I have a pair of angles that are congruent. I also have another pair of angles that are congruent. So right now we have 2 angles, and then this is going to be the important part. The side right here, so we have a pair of sides that are equal. When I look at this example, we see that we have a pair of sides. So is this AAS or ASA? And our conclusion would be, since the side is touching both of the angles, so it is between the 2 angles, we would say this is ASA. So the answer would be yes, it is congruent, and it's by angle, side, angle. Now, on the contrary, why don't we actually look at number 3 real quick? Because in this one, we also have 2 angles. So there's my first pair. There's my second pair. So we have 2 pairs of angles there. And then we still have that third side. But what I'm hoping you can see here is that this side is only touching one of the angles. And so because of that, this would be yes as well, but the reason for it would be different. The reason for this would be angle, angle, side. Now, if you wrote SAA as this problem, that's the same thing, so that's totally okay to do that. And then for the last one, we have a pair of sides, another pair of sides, a third pair of sides, and so number 2 would be, well, yes, and the reason why is by side, side, side. Now, before we wrap up this video, there are two properties that I do want to talk about that we are going to have to use in some problems. So the first one is called the reflexive property. And essentially all we need to know about the reflexive property is that if I have two triangles, so at the top here I have triangle ABC, down below I have triangle ACD, so the second triangle. Notice that these two triangles share this side. And even though this is not marked, what we essentially want to remember here is that if I have this triangle up top and I were to split it with the triangle down below, yeah, we know this and we know this and we know that. But notice that for this side right here and here, technically those have to be the same. And so because they have to be the same, we essentially can mark and say that it's equal to itself, because if I were to take a pair of scissors and cut that side out, they would be the same. So this is still going to be congruent. And it's still going to be congruent by side, side, side in this situation. If I were to ask to be writing a triangle congruence statement, we could say the top triangle is called triangle ACB, and then the bottom one we would call then to be corresponding would be ACD. So that's called the reflexive property. Now there's one other property that we're going to need to use as well, and hopefully you are familiar with this one because this is called vertical angles. And as we know, if we have two lines that intersect one another, as we do in this drawing, the non-adjacent angles, namely angle BCA and angle ECD, they are going to be congruent to one another. And so this is going to actually create that third missing piece that we need. So this is also going to be congruent. These triangles are going to be congruent by, in this case, side, angle, side. And once we have that known, then we could write a triangle congruence statement. That triangle congruence statement would be ACB, we'll call the left one that, and then the right one would have to be called to correspond. This would be ECD. Okay, there we go. All right, so let's try a couple of these before we wrap up our lesson. So there are a total of 6 examples here that I want you to try. So on these more examples, go ahead and pause this one last time and see if you can try these out. So let's look at these first 3 here. In the first one, this is going to be side, side, side. So we had to add in the fact that they did share this side. So I used the reflexive property to get that. Very similar to the sample problem we did above. For number 5, we had these crossing lines here, these intersecting lines, and the non-adjacent angles are equals, so that would make vertical angles. Therefore, our conclusion is angle, angle, side. I'm going to come back to 6 afterwards. Let's go down to these bottom 3 first. For number 7, once again, we have them sharing a side, so we'll use our reflexive property. In this case, we're going to get side, angle, side. Now, this next one we need to be extremely careful with, because number 8, they do have a side in common. That's going to be this one right here. And that is reflexive property once again. Now, if I looked at this top triangle, you'll see that I have an angle that's not between the two sides. So we would say angle, side, side, and that's not going to work. If you remember, that's the side angle or angle, side, side, does not work. So this is not congruent. If you look down here, though, if you only looked at this one, you said, oh, there's 2 sides. There's an included angle. This is side, angle, side. Well, they have to match. So because of that, since this was end up being side, side, angle, this is not going to be congruent. And last but not least, we have this one here. So once again, the vertical angles across from each other, we mark those, and that's side, angle, side. Now, I wanted to quickly reference number 6 here because what you need to be very careful with here is if you didn't remember HL, you might have said the same thing here. You might have said side, side, angle and said that the answer to this was not congruent. In fact, that's not the case simply because the angle is a right angle. That opens the door for our right triangle possibilities here. So we find that there's a pair of legs that are equal, and we find that there's a pair of hypotenuses that are congruent. So this is actually going to be hypotenuse leg. Now, as we wrap up the video, I have one final question for you to think about, and let me just put that up on the screen. So go ahead and take a look at this, read over this, and we will talk about this in class. Thank you for watching and have a great rest of your day.